Okay, so moving on. We're going to start analyzing quadratic functions. Okay, guys. Okay, so review that a quadratic function is degree 2, right? So we're going to actually start looking at the properties of quadratic functions today. So degree 2 in the form of ax squared plus bx plus c. We also call these parabolas. Quadratic function is a parabola. So we need to talk about some basic characteristics. Well, if you have a U shape, so opens up or down, if it's opening up, are you going to have a maximum point or a minimum point? Looking at that minimum. You're going to have a minimum because you're opening up. So it's going to start at a minimum point and then keep going up. So parabola that's opening up will have a minimum. A parabola that opens down, if it opens downwards, it's going to have a maximum. Okay? So that's important to know, right? To know that if it's opening up, it's going to have a minimum value. Opening down, it's a maximum value. The vertex, so the max or min value, that point, it's going to be x comma y, we call that the vertex. So the maximum or minimum point. So not just how high or low does it go, but actually as a point is what we call the vertex. Is a minimum or maximum point. Okay. And the max or min value of a quadratic function is a y coordinate. So when I actually say what's the max value, I just want the y value. Because the max or min just tells us how high or how low it goes. Not where the x is, but just where the y is. So let's complete, there's a chart here. We're going to complete the table of values for this function. So we have x squared minus 6x plus 5. So now our input, our x, is going to start as -1. So with your calculators, how would you type this in? Just like we want x equals -1. Would you have to put your -1 in brackets? Yes. Whenever we sub, put it in brackets, and then you're not going to make a mistake. No, we're just subbing it in. So -1x squared. If you're graphing, you wouldn't have to. Okay. So -1 plus 5 gives us, so we're subbing in our x value to figure out its y. We're making a table of values. Gives you 12. Okay, how about 0? Plugging in 0. 5. Yeah, the constant is always going to be your y-intercept, because 0 squared is 0, minus 6 times 0 is 0, plus 5. Okay, 1. Let's see, 1 squared minus 6 times 1 plus 5. Not this time. 0. Okay, 3, do 3. 3 squared. So 3 squared. Okay, you should finish this off. So finish off the rest of the table. Figure it out. Because you're waiting for me to do it. -4. Okay, figure out now 5. What was 5? 0. Okay, so let's plot this on the grid that they gave us. -1. So here's our x-axis and our y. -1 and 12, was it? There. Then they give us 0, 5, 1, 0, 2 and -3, 3 and -4, 5 negative 3, 5, 0, 7, 12. Let's plot those points. Okay, so whenever we have y equals an equation, we connect them. Now, is it going to be a straight line? No, it's going to be curved. Smooth as you can. It's hard. This one didn't turn out as nice as last one. I know. I tried. Well, it's the angle too. Okay. So we need to answer some questions about this. Okay, so here it says draw a vertical line representing the axis of symmetry. So an axis of symmetry is where you can literally take the graph and fold it in half. It's like the mirror. Yeah, where would it be? Where? Here? Here? Yeah, it'll always go through the vertex. So this is where your highlighter is going to be really nice, because we want to draw a vertical line dashed all the way up. So that's called the axis of symmetry. Okay, axis of, yeah, so that's where it's symmetrical on each side. Axis of symmetry. Okay, so it says the graph of a quadratic function is it a parabola? Yeah, is a parabola. The word parabola? Could be, yeah. So what's the vertex? What point is our lowest point? So what's x here? X is 1, 2, 3, comma, y was, Jesse, you said it? Negative 4. So the vertex is that point, that the lowest point. So that'd be 3, negative 4. That's for the max or min value. The vertex, we want the point. Now here, is the parabola opening up or down? It's opening up. It's like a smiley face. If we added 2 eyes right here. Opening up. And therefore has a minimum. It's going to be a minimum value. So a minimum point. So what is the minimum value? Would be the y value, negative 4. The minimum value is a negative 4. Okay, what's the x-intercept? So what's values here? What is this? This is 1 and 2, 3, 4, 5. So the x-intercept is where we cross the x-axis. So 1 and 5. And the y-intercept is at, so where's it across the y-axis? 5. Okay. So the equation of an axis of symmetry, remember it's a vertical line, and all vertical lines have an equation of x equals a number. So what's our x value at this point? It's always, no, the x value. 3. X equals 3. So our equation for the axis of symmetry will be x equals 3. It's x equals whatever that value is, at the x value at the vertex, or minimum point. Okay? So that would be the vertical line, x equals 3. Yeah, so always just look at your vertex to get your axis of symmetry. And always look at your vertex to get your max or min value. The domain of the graph. Okay, so will this graph keep going? Remember Dr. XY. So domain, we're talking about x. So domain x. We'll keep going to the left and right. Yeah, we would say element of x is an element of the reals. Now, range. We'll always have an inequality in our range. Is it going to be, so it's going to be greater than that minimum value. If it was a maximum, it would be less than. So y is greater than or equal to negative 4, the y value. So it starts at negative 4 and then keeps going up. Okay, so you can also get the, I'm going to show you another way to get your axis of symmetry. And we can use our x-intercepts. If we add, because it's symmetrical, If we average the x-intercepts, that's going to give us the middle point, because our axis of symmetry is going to always be halfway between our x-intercepts because it's symmetrical. So what was our values for our x-intercepts? 1 and 5. So how do you average two numbers? Add them together and divide by 2. So 6 over 2 or 3. So x equals 3, right? So that's another way you can use your x-intercepts to get that middle point. And then that also tells you where your vertex is at. We're going to use that a lot this unit. Okay, so I'm going to teach you how to find the max min value on your calculator. So you need to get your calculator out and turn to the next page. I know. Yeah, I know. Okay, I just want to point a little note. Remember that degree 2, it's actually the highest degree that tells you what the graph will look like. Okay, so right now, the number in front of x squared is going to tell you something, but more particularly the sign. So if you have a negative sign in front of the x squared, which way do you think it will open? Down. It will open down. Okay, so we just look at the sign in front of the x squared value, and if it was positive, it would open up. Negative, open down. So grab your graphing calculators. Let's go to y equals. We're going to graph this value. Negative x squared plus 5x plus 14. And make sure, we're going to adjust our windows. Now remember, this constant, that 14 at the end, that's going to be your y-intercept. And we said this guy's opening down. You always have to go probably a little bit higher than that value, but it gives you a hint of your windows. If I graph this just the way it is right now, I can't see my max value. You always have to be able to see your max or min value to get it on your calculator. Just like you need to see the intersection to get the intersection. So we need to change our windows. We need to go higher. They tell us what windows. Zoom 6 goes standard. Zoom 3 zooms out. We're going to actually just go push the window button, and they tell us what to go to. So they went negative 5 to 10 because we didn't need that extra part on the left of the graph. And we went high. They want to go higher for their y value because they know, oh, it's up above more. So they went negative 5 to 30. And a scale of 5. Okay, both of them were scales of 5s. You can leave it as a 1 if you like. And now go graph. So now we can see, ooh, there he is. Now we're going to see our max or min value. Yeah? You have to figure it out. So then you can just zoom out if you have to. Great. Okay, so the question was if you'll get the window values. But you'll have to just figure out the windows yourself. Okay, so how do we get the max or min? Well, very similar to intersection point. We're still going to go second trace. Nope. Okay, because there's no intersection. Which one do you think we need? In this case, we're going to have a maximum because it was opening down. So number 4. Okay, so we want the maximum. Now this is very different than what we've done before. It says left bound. So what it's saying is I need you to go to the left side of your maximum. So we have to use our arrow and scroll to the left, somewhere to the left side of it. As long as we're on the left, it doesn't matter how far we go. Push enter. Then it says right bound. So now they want us to go on the right side of our maximum. So notice these two arrows. These two arrows here, there's one here and one here. They're saying my max or min value is between these 2 points. So we want them to say, find the max value inside there. Okay? So then it says guess. So then you can go and make a guess. I think it helped the calculator out somewhere in there. Push enter. And then after the 3rd time, it's giving you your max value. So our max is 2.5. Our min is 20.25. Okay? Now, what if I actually wanted it as a fraction? Does your calculator store the x and y? Yes. So what could you do? Quit, x, math, enter, enter. 5 over 2 is the same thing as 2.5. And alpha 1 alpha 1, math, enter, enter, will give you your y value, 81 over 4. Okay, so that's alpha 1. To get y, alpha 1, 1. Alpha is the green button. Okay, so all of this, there we go. So let's move on. So that's using your calculator. Okay, so we're going to try it again. Now, just looking at this graph, looking at the number in front of x squared, it's going to open up or down? It's going to open up because it's positive. So positive, open up. So if it opens up, are we going to have a max or a minimum value? Looking at the picture, minimum. Okay, so state the appropriate window. So let's see what windows we need to change this to. So grab your graphing calculators. Let's graph it and go standard to start off. Y equals. Bean, you with us? Okay, 2x squared minus, yeah, Jesse? Quickly. Plus 15. Okay. Now, just go zoom 6. So we're going to go regular windows to start. Zoom 6. Ooh, we can see it. Our windows are good? Yeah. Would we need to change them? Zoom 6. Zoom 6. So right now, it says state your windows. So we use square brackets. So x. Then we go minimum, maximum, scale. So we went negative 10, comma, 10 to 1. Min, max, scale. It's on your formula sheet too. And then the y value, again, negative 10 to 10, scale of 1. Because that's a standard setting. So we're good to find, it says, determine the coordinates of the vertex. I want you to try that on your calculator right now. Try to find the vertex again. Second trace. So calculate. So you want the calculate button. And now you have to figure out it's a minimum. So number 3 this time. Okay, so then use your arrow. So right now mine says x is 0, y is 15. It's way up there. So I have to right arrow and come down. So now it says left side, enter. Anywhere on that side, yeah. And then right side, guess. Okay, so let's talk about that. Kayla says she had 3.250001. Anyone else have that? Anyone else have 3.24999? Yeah, so what is it probably? Somewhere, it's calculating it, and it's really close to 3.25. 3.25. So so that's what it is, 3.25. So sometimes your calculator will do that. It's like super, super close, but the actual value is 3.25. So x was 3.25, and what was y? Negative 6.125. Okay, could you write it as a fraction? Yeah, so calculator. Let's see how it does for the first one. X, math, enter, enter. No, it's giving me an issue. But we know it's 3.25, so what could we do instead? 3.25, oops, that's a 2. Math, enter, enter. So it should be 13 over 4. Or 13 over 4, comma, the y is good. It didn't give us any issues. So negative 6.1, so alpha 1 for y. Alpha, not second. Math, enter, enter. Negative 49 over 8. If I ask for a fraction, so sometimes I'll ask for decimals. Decimals are actually really nice because if you're graphing it, you're going to need it as a decimal. Right? So often we'll leave it as a decimal. Many uses. You should know what a fraction is, right? You know what a half is. Okay. Lots of uses. Adding fractions can be easier than decimals, right? I know I have 3/8. Well, as a decimal, that would be like if you're a carpenter. Okay, anyways, on backtrack. Explain how to use the coordinates of the vertex to determine the equation of the axis of symmetry. The equation of the axis of symmetry. So we said this is opening up. We saw it opened up. It had a minimum value. If we plotted this, the minimum value would be 3.25, comma, negative 6.125. Where does the axis of symmetry go? Right between them. Okay? So what would be the equation of the axis of symmetry? X equals what? 3.25. Just the x value in the vertex is the equation of your axis of symmetry. So take the x coordinate. It says explain, so we have to use words. So take the x coordinate of the vertex and write it as x equals. X equals the x coordinate that we got. Make sense? Okay. Determine the x and y intercepts of the graph. The x and y. So let's see if we can look on the graph and figure it out. So look on your graph. So let's start with the x-intercepts. Might have a problem here. Now, there's a couple ways we can do this. We can figure out one of them, right? Can you see that? Let's change our window so it's a little bit more clear. Okay, so let's change our windows. I'm going to change our windows. So the x, we didn't need all that room, so maybe we'll go negative 5. We'll leave it to 10. Now, how high should we go? Let's go a little higher. Could you see your y? Initially, could we see our y-intercept? No. So let's go. Remember, our minimum value is negative 6.1. So we can go negative 8 to maybe 20 for y. And now let's push graph. Okay. So can we see one of the x-intercepts? Yeah? How far? Where? What is it? 5. Okay. So remember, so one of the x-intercepts equals 5. Now remember, if this guy is 5, is the distance between your axis of symmetry and each intercept going to be the same? Yeah. So if this guy was, what's the difference between 3.25 and 5? 1.75. So the other x-intercept is going to be 1.75 the other direction. So 3.25 minus 1.75 gives you what? So our central point was 3.25 minus the distance, 1.75. So it would have to be what you thought it was, Jesse, 1.5. 1.5. Because that distance from the axis, if we can figure one out, we know the distance away, we can figure the other one out. Okay, y-intercept, it's really easy. We just set our x to 0. Okay, so y-intercept, set x to 0 in your equation, what would y be? No. So y-intercept, 15. So this last number, this constant, is always your y-intercept. Just like, remember when we did y equals mx plus b? The constant there was always the y-intercept. Because if x is 0, the other guys are 0, we're just left over with the constant. So the y-intercept is 15. Okay. It says use the x-intercepts to verify the equation of the axis of symmetry. Remember, if we take our x-intercepts and average them, what should it give us? Does that give us halfway? If we average two numbers? Yep. So 5 plus 1.5, 6.5 divided by 2, like 3.25, which is our axis of symmetry. Okay? State the minimum value. What's the minimum value in this graph? What was the minimum value? So how low did this graph go? Yeah. Or you could have also wrote negative 49/8. Right, if there's a fraction. So the minimum value is just the y value. And then last, we'll state the domain and range. So what would be the domain? Will it keep going to the left and right? Yes. So x, e, r. Range. So looking at our graph, how low did the graph go? There was a minimum value at negative 6.1 greater than or equal to. So once you know that minimum value or max value, that's going to give you your range. Y is greater than, because it's a minimum, negative 6.125. Yeah. Okay, keep going. It is. You're going to practice. And then these videos will be online if you need to watch them again. Okay? So the coordinates of the vertex of the graph of a quadratic function can be determined from the axis of symmetry. So what it's saying is, if we know the axis of symmetry of a graph, see, this is x equals 2, we know always that that axis symmetry is also the same number, our x number, in the vertex. Right? So this is going to be 2 comma some number, our vertex. Now, why do I know that this graph is opening up? Because the number in front of x squared is positive, so it's opening up. Yeah. So, without a calculator, find the vertex. Well, we already know the 2 for x. Could we plug it into the original to get the y? Yeah. So, y equals 4 times 2 squared minus 16 times 2 minus 9. Okay, let's just type that in. Oh, without the calculator. Okay. 4 times 2 squared is 4. 4 times 4, 16. 16 times 2, 32. Minus 9. What's negative 32 minus 9? 41. And 16 minus 41, negative 25. Yeah, negative 25. Oops, equals negative 25. So what would be the vertex then? What was the x? 2. X was 2 comma negative 25. Right? So the axis of symmetry, that x value is also the x value in the vertex. That's a question mark over there. Okay. Turn the page. Keep going. We're almost done. We're almost done. I want you to skip that page and just go over to the next one for a sec. So go over to summary of the characteristics. And then we'll do a little investigation together. So the shape of the graph is what we call what? A parabola. It's a parabola. And what other shape can you kind of compare it to? Not a V, a U. It's kind of a U shape, right? So the graph is symmetrical about the vertical line called the, what do we call that line that it's? Axis of symmetry. Okay, if a is greater than 0, so a was this number here in front of the x squared, it opens up. Remember, greater than 0 means positive. And the vertex then, if it opens up, it's going to be a max or a min? A min. A min value. Okay? The y coordinates of the vertex is the blank blank of the function. Well, okay, so it's the y coordinate is the same as the the minimum is the word I was trying to say. It just came out. Minimum. It's a minimum value. Okay, so when we find our vertex, that y value is our minimum value. So if a is less than 0 or negative, then it opens down. Okay? I'm not answering that right now. Okay, so if it's opening down, then the highest point is what we call a maximum. The y coordinates of the vertex is the maximum value of the function. Too much speaking in one day. Okay, what will the domain always be? Elements of the reals. Okay, now, this last part we need to talk about. If c is greater than 0, so remember c, what is c? Close, not the x-intercept, but the y-intercept. So y-intercept. So c is always the y-intercept. So if c is positive, it's going to be above the y-axis. If c is negative, then it's going to be below the, or negative, sorry, positive. A positive y, I didn't read the question rest of it. So it would have a positive y-intercept if your c value is positive, and if your c value is negative, then you'd have a negative y-intercept. Okay, so here, guys, is basically a summary of this lesson, right? So your vertex being your minimum point if it opens up, axis of symmetry is your x equals a number. Okay. Now, just a really quick investigation. I wanted to show you a couple graphs. Okay. So what if we change A, B, and C? So just really quickly, just sit and relax as I'm going to go through this part here. So just sit and watch the calculator. Yeah, it won't take long. Okay, so what we're going to do, I'm going to put zoom normal. Okay, and I'm going to take my graph. I'm going to start by graphing just the most standard basic quadratic equation. What do you think the most standard basic quadratic equation is? X squared. Okay? So what if we change the value of a? We're going to just really quickly, what does that a value do? Now we know if it's positive, it opens up. If it's negative, it opens down, right? What if I make this a value 2x squared? What do you think will happen? Let's see. Does it still start at the same point? Yeah. What happened to the graph? It just became, or it's actually stretched vertically. It's a little bit steeper, right? What if we make it a half value? What do you think will happen? It will be what? Compressed, right? It's not as steep, yeah? And so it becomes wider. So that's the value of a. Now b, so if we have ax squared plus x, that's the most basic equation. Okay? So what does adding x value do? Does it go through the 0, 0 anymore? Well, one point goes through here, but now there's another intercept. So what if I'm just going to change my windows to -5 to 5, so you can see that a little closer. Okay, see? Still going through 0, and it's going through 1. So what if I go x squared plus 2x? I still go through 0 and 2. So what does it change? What is the b value changing? The x points. What do we call these points on the x-axis that it crosses? The x-intercepts. One more second. Okay. The c value, very quickly, if I had x squared plus, let's say, 1 versus x squared plus 2. What do we say that constant does? It's your y-intercept. So If I graph the first one versus the second one, the C value changes the y-intercept. So really quickly, A value changes the steepness and opening. Okay? The B value changes the x-intercepts. And the C value changes the y-intercept. Okay? So those are the effects on those variables. So tomorrow, both assignments all. You'll have the whole block to work on.